This next segment is hydraulic fracturing and water resource protection. The next graphic attempts to identify key aspects of oil and gas operations surrounding hydraulic fracturing and where water resources need protection, including during transportation of chemicals to a site, on-site handling of chemicals during mixing and injection into the subsurface, well pad containment features such as blowout preventers on the wellhead, lined well pads, berms, or fences, casing and cementing of the well to isolate drinking water aquifers, separation of the hydrofrac zone from drinking water sources, and containment of flowback and produced water for storage, treatment, reuse, and disposal. And finally, transport of wastewater for reuse or disposal. I would now like to discuss risk management best practices that segments of industry have identified to protect water resources for oil and gas operations. This includes site selection and well pad construction, construction of the production well, well completion or hydraulic fracturing of the well, and wastewater management and well closure. Under the heading of site selection and well pad construction, it is important to identify shallow gas producing zones and the base of fresh water. This is especially important when moving into a new area. This is accomplished by examining existing information and by doing resource surveys using geophysical methods and tools. The use of physical containment on a site is important to protect against runoff, spills, and blowouts. Many operators now line their pads and berm them with soil or metal fencing for containment of spills. More and more states are now requiring operators to sample water wells in the immediate vicinity to determine baseline water quality. We will discuss this in more detail in a later course segment. And it is important to identify source water locations and have contingency plans for water shortages that may arise due to climatic factors. Evaluate competing uses of source water in the area and the timing of water withdrawals in the context of other water uses and potential drought conditions. In terms of risk management for well construction, numerous studies suggest that effective reduction in risk to water resources should be focused on proper well construction methods and confirmation of well integrity. That is, that the well does in fact isolate freshwater zones and other gas and oil producing zones. Potential problems do arise from shallow gas systems, casing leaks, and poor cement jobs. There are a number of well integrity tests that can be performed, including pressure testing, cement bond logging, and temperature tests. Portable GCMS instruments can be used to detect stray gas issues emanating from shallow gas sources into the well. Cement bond logging can evaluate the quality and the cement bond and identify where void spaces exist or where cement may be present but is not bonded to the well casing. A combination of different testing methods usually offers the best assurance of verification of well integrity. Risk management practices associated with production well completion or the hydraulic fracturing process itself. Here, it is essential to have continuous monitoring of the downhole, annulus, wellhead pressures to ensure successful delivery of fracturing fluids to the targeted zone. This consists of real-time monitoring of treatment progression from a nearby command trailer. It is important to use approved tanks for clean water storage and storage of chemicals and flowback fluids. It is also recommended that there is follow-up monitoring of nearby water wells after the hydraulic fracturing of the well. Some other recommendations are to not frack in or immediately adjacent to an underground source of drinking water. This should be obvious, but it has happened. Also, have contingency plans for accidents, such as blowouts, other well failures. These things happen. Recent ones, indeed, have happened in Oklahoma, Pennsylvania, North Dakota, and West Virginia. With respect to risk management practices and wastewater management and well closure, the use of tanks on site will reduce risk from leakage or overflow issues from waste pits. Pits, when used, should be double-lined and equipped with leak detection sensors. It is recommended to recycle the flowback water to the extent possible. This is becoming a standard practice, especially where source water is limited. Recycling often can reduce costs for both fresh water and chemicals. On-site treatment is expensive in most situations, but may become more important if waste disposal options become limited. In terms of risk management practices for well closure, there are standard practices to follow for plugging the well at the time of well closure, with materials that are optimized for the local hydrogeology in terms of the cements and the bentonite that is used. It is important to verify the plugging, verify that it is effective. Site reclamation is then conducted to restore the site back to native vegetation and natural contours. Finally, a recommendation is communication with all stakeholders, especially the public, during all phases of oil and gas activities. This will reduce costs, increase profit margins, and gain operators a social license to operate from the public in an area, in an atmosphere of trust.